Infectious diseases have overwhelmed humans since ancient times. But even during these early days, humans were aware of the effects that changes in climate were having on disease. Flocking to the seaside during the summer months for many seems second nature, but this tradition dates back to Roman times, in which wealthy citizens would flee the cities to avoid diseases that came with the heat. But what are infectious diseases, and how are they caused? Infections that affect humans are caused by microorganisms such as bacteria, viruses, fungi, and parasites. These can be categorized into two groups: anthraponoses, diseases transmitted from human to human, and zoonoses, diseases transmitted from an animal to a human. They can be directly transmitted, where there is immediate contact, or indirectly transmitted, where an additional organism acts as a carrier of the disease. One example of this is that of the parasite Plasmodium that lives on mosquitoes. A single bite from the mosquito can spread the parasite and cause the disease malaria. Mosquitoes relish warm temperatures and humidity, as these are the ideal conditions for their growth and survival. Rising levels of humidity and warmer temperatures brought about by climate change may lead to an increase in malaria transmission, particularly in already susceptible regions such as Africa and India. Evidence suggests that areas of the world with previously milder climates, such as the UK and Europe, may see an emergence of new diseases as these countries start to exhibit the effects of climate change, such as increasing temperatures. So what evidence do we have to suggest that there is a threat from diseases linked to rising temperatures in the UK? After all, apart from the occasional heatwave, our climate currently seems a far cry from the intense heat and humidity seen in tropical areas. It turns out that we don't need to look any further than our own seabeds. Oysters and mussels are mollusks that are farmed at the intersection of rivers and the open sea, where the salt concentration is a mixture of fresh water and seawater. Mollusks typically feed by taking in seawater and sieving out as many of the nutrients they need, and are therefore termed filter feeders. Filter feeders are important for the health of our environment, as they remove pollutants and release clean water into their surroundings. Most people are aware that eating shellfish, like raw oysters, undercooked prawns and mussels, might be followed by a short bout of vomiting and diarrhea, sometimes termed gastroenteritis or food poisoning. This is not caused by the shellfish or food product, but instead is due to bacteria that has made its way from the seawater into the shellfish. The filter feeding process can lead to the build-up of harmful bacteria within the oysters to levels that might cause someone eating that oyster to get sick. Vibrio parahemolyticus is one marine bacteria that loves to live inside shellfish. It loves warm conditions and low salt concentrations, and it just so happens that climate change is creating the perfect environment for Vibrio bacteria to grow. The continued warming seawaters around the UK coast, along with heavy rainfall events, which lowers the salt levels, means that Vibrio bacteria have the ideal conditions to flourish here. 30 years ago, Vibrio bacteria were rarely present in the UK waters or around Europe. Cases of food poisoning linked to Vibrio bacteria were sporadic and travel-related. Now scientists can find Vibrio bacteria every summer in the UK due to rising sea temperatures, especially on the south coasts, with low numbers of cases being reported each summer. Does this mean we are safe in the winter? What happens to Vibrios in the winter months when temperatures are much colder? Well, Vibrios have an additional skill: their ability to become undetectable. You can think of it as a superpower. During the winter, sea temperatures are too cold and nutrients such as salt are scarce to support the growth of Vibrio bacteria, leading to most of them dying. However, research shows that some Vibrio bacteria, instead of dying, go into a sleep-like state. These sleeping Vibrio cells are still alive but do not reproduce, and they go from a healthy rod-shaped structure to a round shape in order to help preserve their energy. They also develop an extra layer on their surface to help resist any damage while in this sleep state. Scientists cannot detect these sleeping bacteria using their normal methods, so they often go undetected. This means that when oysters are examined for the presence of any harmful bacteria, the sleeping Vibrio bacteria remain hidden. Once the winter months are over and it starts to warm up again for spring, the Vibrios start to emerge from their sleep-like state. The bacteria can be woken up by certain stimuli, a bit like how an alarm clock or the smell of coffee might wake you up in the morning. Instead of coffee, the Vibrio bacteria can be revived by warm temperatures and the right sugars, including one in particular called lactates. How do bacteria sense these cues? And are there other such cues in the environment that we're not aware of? How do these sleeping bacteria protect themselves from the cold temperatures? How dangerous are they in this sleeping state? Dr. Sarika Wagley at the University of Exeter is attempting to answer these questions by investigating the properties and behaviour of these sleeping Vibrio bacteria. As climate change leads to increasingly favourable conditions for the growth of harmful bacteria such as Vibrios, the need to study and monitor them is essential in order to protect our aquaculture industry and reduce the risk to human health.